was pretty abstract. Yeah. Pretty abstract. Yeah. So I want to use a concrete example to show you step by step what happened. So there are 4 steps. After each step, what happened for the 2 tables? How to join them? What are the states after those steps? Yeah. All right. So let's look at D.5 illustration using an example. Yep. Sorry, I need to connect my remote control. Yeah. So this example I select from that company example. Yeah. All right. Yeah, this example. Yeah, actually we did this one, table join, right? So our first table join example. But here I show you step by step what happened after each step. What is the state after each step? Yeah. All right, so let's start. I use, charts, draw the joined table to show you. All right, when we start, we have a employee table with 40 rows. So in the parentheses, you see 40. Oh, I need to change the pen color. Yeah. Click something wrong, right? Select the wrong option. Yeah. All right, yeah. The number of rows in the parentheses. Yeah. 40 rows. Yeah. How many columns? Yeah. So later I'll give you all those numbers. Department table, 6 rows, 6 departments. Yeah. All right. And here we use the row notations S1, S2 through S40, representing these 40 rows. Yeah. This side, department side, T1 through T6, 6 rows here, ST. Yeah. Because we need to use these notations to represent the cross product, Cartesian product. Yeah. The first step, we do the Cartesian product. Okay, so with S and the T's, yeah, so we can write the, the joined tuple, yeah, easily. Yeah. All right. So Cartesian product, employee table cross Cartesian product with department table. Yeah. The number of rows before we apply any condition. So here we don't do that where clause. Yeah. The first step, we only join 2 tables with all the possible combinations. Yeah. So what do you see? 240 rows. It comes from 40 times 6. Remember, we introduced a concept called cardinality. Cardinality of this joined table equals the product of the 2 cardinalities of those 2 tables. 40 times 6. So you get a, much bigger table with this many rows. Yeah. Then the row structure, you also want to see the row structure. Yeah. S part and the T part. Yeah. The first part, you take the S tuple. Second part, you take the T tuple. So you put together, yeah, S part first, then T part after S part. Okay? Yeah. So you get a larger tuple. Yeah. All right. So the first one, yeah. So we like to follow some order. So S1 T1, yeah. S1 T2, S1 T3 through S1 T6, then S2 with each T, yeah, and so on. Yeah. The last one S40 T6. Yeah. In this way, you get a 240 tuples. Yeah. All right. Yeah. So that's the first step. Yeah. Then, S part, there are 10 columns. Employee table, there are 10 columns. Yeah. And department table, there are 4 columns. Yeah. Then, the joiner table, you need to combine, yeah, from these two parts, so you have total 14 columns. 10 plus 4, 14 columns. Yeah. 10 plus 4, yeah, in the joiner table. Okay? Yeah. All right. Then, now we need to apply 2 conditions. Yeah. The first time join condition, second time select condition. Yeah. To eliminate many rows. Yeah. All right. So before we do the eliminations, yeah, so we have 240, 14 tuples, yeah, 14 rows, yeah, yeah. 14 tuples. Each row, there are 14 attributes. Yeah. Yeah. All right, so, yeah. And now this is the join condition. Okay, this is the join condition. D null equals D number. Yeah. In these 2 tables, yeah, these 2 values should be the same. Yeah. But in these 240 rows, many of them, this condition is not satisfied. Many of them, this condition is not satisfied. So if this condition is not satisfied, we cross out, we eliminate them. Okay? We only keep those rows that satisfy this join condition. Yeah. So only, that part left. Yeah. So then, after elimination, there are 40 rows remain. Yeah. So these 40 rows satisfy this join condition. Yeah. So 200 rows gone. Okay? 200 rows do not satisfy this join condition. Yeah. All right. Then, this is step number 2. Step number 3, we apply select condition. Research department, remember? We need to make sure the department name equals the research. Yeah. It's the selection condition. So then, we need to cross out those rows whose D name not equal to research. Yeah. So cross out, yeah, all those rows. Yeah. And only 4 rows left. Yeah. So after step number 3, we only get 4 rows that satisfy these 2 conditions: join condition, selection condition. Okay, all right, yeah. But this is still not the final result, yeah, because these 4 rows still, they contain 14 columns, total 14 columns. We don't need all these 14 columns, right? Yeah. So we need to do the last step, projection. Yeah. Based on the query statement, we only need to take 3 attributes, right? 3 of the 14 attributes. So the last step, projection, F name, L name, and address. We only take the information corresponding to these 3 columns. All right, yeah, so that projection. So we get the result, the query result should be 4 3 tuples, 4 rows. Each row contains 3 columns. That's the final result. Yeah. All right, yeah, so you display the result. Okay, yeah, so you complete. Yeah. So with this example, you understand the whole procedure. So what happened behind the scene after that join? Yeah. Remember, here we use the default join. Default join, that's the inner join. Okay, yeah, but we do not need to say it, right? We do not need to use the inner join. Yeah. But if you look at the W3 school examples, yeah, so you can see some examples it write inner join explicitly. Yeah, yeah. That's okay. That's just the different ways to write to produce the same output. Yeah, there are many different ways. Yeah, so you can learn different ways. Okay. Yeah. All right. Yeah. So here, this way we use the default join way. Yeah. Not explicit, implicit. Yeah. Here, the join keyword is implicit. Yeah. All right. Then, all right. So we finish part D of module 3. Yeah. But before we move to part 4, before we move to module 4, part A, I want to explain one thing. Yeah. Remember, I post the homework assignment number 1 Sunday. Yeah. Sunday evening. Yeah. So there are 14 query questions. Yeah. 14 select statements. 8 of them, 10 query statements. 8 of them table join. Yeah. 2 on single table. Yeah. You only need to use the query from 1 table. Yeah. But 8 join two tables. Yeah. Then one thing I would like to let everybody know about what do I expect? Yeah, how to write? Yeah, because although I believe most of you know how to write the query statements, but based on my experience, before, yeah, a few semesters before, some students, so they didn't understand the requirement. Yeah. Some students just give me the query results, these tables, okay? Yeah. Copy the query results. Yeah. So they use their eyes to find those rows satisfy the condition. Then copy those query results. That's not what I want. Okay? You do not. So this query results, that's after you run your SQL statement against the database. Yeah. That's what you get. So that's the DBMS produces. Yeah. But what do you give me? You give me the query statement. Let me move to the previous slide. Here. What I need is you write this query statements. All right? Yeah. That's your answer. This is your answer. All right? Yeah. Each query question, you need to write the select statement. Yeah. You do not write the result part, okay? Yeah. Yeah. A few students in, a few semesters before, several, actually, yeah. So they just, copy the result tables. No, if that one you cannot get any point. Okay, so you need to practice how to write this select statement, this part. Okay, then after you run this select statement in your DBMS, you can see the query result, but you do not need to give me the query result, right? I do not need to see your query result, okay? Yeah, I just want to see your query statement, okay? Yeah, because if I need, I can copy your statement, select statement, then I run it in my DBMS, so I can see the result, okay? Yeah, sometimes if I want to check if your statement is correct, then I will run your statement. All right, so that's my expectation. I hope nobody understand this wrong. Because I saw several students did this kind of things before. So in this chance, I want to let you know the requirement. All right, so now let me move to Module 4. So we learn some more features, improved methods on the select statements. All right. Module 4, Part 8. More select statements and insert, update, delete statements. Because the last three very easy. So we can quickly finish the last three types of statements. Then we spend more time on the select statements. 8.1, resolving ambiguity in select statements. Alias. So far, we haven't used the alias, although I mentioned that. Last time I mentioned that alias a little bit. Here, let me explain that alias because it's very convenient. So after we learn this alias way, then later, we will use a lot of alias to help us write the select statements better, because we can understand the statements better. All right, first example, handling ambiguity. So let's look at this query statement. Question, for every project located in Stafford. Location, okay, the project located in the project table, location. You can see the location information. Stafford. List the project number, the controlling department number, and the department manager's last name. So here, you can see we need to join two tables, project table and a department table. Actually, three tables, right? Because if you use department, is still not enough. The last name of the department manager, it's in the employee table. Okay? You need to join three tables here. Okay? The questions I give you in the homework assignment number 1, I didn't give you any question join three tables, only two tables. Because the first time we only practiced two table join. operation. Yeah. But here, this one, we need to join 3 tables. All right. Project table, department table, manager's name, that's the employees table. Okay? Yeah. So join these 3 tables. Yeah. So then we need a 2 join condition. Yeah. How to join? Yeah. Join. Yeah. Yeah. Although you may have different ways. Yeah. Like this. Let's look at the answer. Yeah. Answer, the from clause, you list 3 tables. Okay? All right. Yeah. Then, where clause, you need to give 2 join conditions and 1 selection condition. One is dnum and d number. Yeah. Dnum and so in the project table, dnum, and department table, d number. Yeah. Should be the same. Yeah. Then department number, you have manager underscore SSN. Yeah. But the employee table, you have SSN, so they should be the same. Yeah. Second join condition. Okay? Yeah. So after that, you join 3 tables. Okay? Yeah. If we use the Cartesian product, cross product, this time you do A cross B cross C. Okay? Yeah. It is well defined. Okay? Yeah. So you join 3 tables. Yeah. All right? Yeah. 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 3 table, if we use SI for table A, TJ for table B, and RK for table C, okay, notation, then the Cartesian product, larger tuples with the first part as SI part, the second part TJ part, then the third part RK part. Okay? Yeah. Each row has structure like this. All right. So after that, then you apply selection condition. P location, project location, P location. Yeah, there is a field in the project table called a P location. Equals the scaffold. Okay. Then projection, the last step, because you only need information from these 3 fields in the joined table. So you get a final result. All right. Yeah, but in this answer, there is a problem. There is a problem for understanding. So if you want to understand this select statement well, ambiguity problem. So that's what we need to find some way to handle the ambiguity. Because when you write the field names, you do not, because it's not that clear which field comes from which table. That information is not quite clear. Okay? Yeah. That make your understanding not that clear. Okay? Ambiguity. So you want to make that part look better. Okay? So you want to clarify that ambiguity part. Yeah. So the solution is very simple. Yeah. So all right. Yeah. Yeah. So the first way actually we did before. Yeah, I mentioned that. Add the qualifiers using table names. Yeah. The first way, in order to clarify that ambiguity part, yeah. So you add table name directly, okay? Yeah, table name directly. So join condition, yeah. But, so this way, if it is this way, you know, it's not efficient, right? So you type the full name, full table names. Yeah. That's not very efficient. Yeah. So you want to save a lot of keystrokes, okay? Yeah. So you don't want to use this, you know, yeah, because you need to type a lot of characters. Yeah. So improved ways, alias-based solution. Yeah. So you need to define alias. After you define aliases, then you can use very short alias names to, you know, make the, you know, we call the qualifiers as the qualifiers. So you can make the whole statement much easier to understand. All right, so let's create an alias for each table name to avoid repeated typing of long table names. An alias can follow the keyword as. Now, when you define aliases, you use this as keyword, okay? Yeah, all right. Or it can directly follow the relation name. Yeah, this as keyword can be omitted. You do not have to, you can even save that as keyword. You just type alias right, follow the field name. Yeah, relation name. Yeah, not field, table name. Yeah, table name. Okay, table name. Yeah. All right. So let's look at the first time we do not omit as keyword. Okay, project as P, department as D, and employee as E. Yeah. Yeah. Although if you skip as keyword, still works. The same thing. Yeah. Yeah. So if you want to save a few more keystrokes, yeah, then you can save more. Yeah, but many people, they still keep the as keyword. Yeah, some people, they like to, you know, make the alias look, you know, stand out easier. So they like to use as keyword. So that's your choice. Okay. So which way you like. Yeah. All right. After that, then it's much easier. Okay. The project table, you just type P dot D number. Yeah. Department table D dot D number, and so on. Okay. Yeah. So then this version, you can see, you can get a much better understanding than our, you know, previous two versions. You know, the first version, you know, too much ambiguity, right? Too much ambiguity. So most people do not feel comfortable to understand the first version. Yeah. The second version, you know, you type the long table names, still not very good. Yeah. So this version, you know, much better. Okay. Yeah. Using aliases. All right. Right. And there is another case. So there is another case. Yeah. Two different copies for one table. Yeah. So actually we join two tables, but those two tables come from the same table. Yeah. Yeah. That is, we do A cross A. A table join with A table using the Cartesian product. A cross A. Yeah. Sometimes we need to do that. In this case, you have to use aliases. Otherwise, because same table, you get yourself confused. Okay? Yeah. So you make two copies of the same table, then you join these two copies. Yeah. In our homework assignment, we have one question of this type. Yeah. So here, let me show you one example. Yeah. This time you cannot skip aliases. Yeah. Otherwise, you have big trouble. Okay. All right. So let's look at this example. Yeah. Here you can see we use the same employee table, but we use two copies of the same table employee. The first copy, we use alias E, yeah, E copy, yeah, employee, yeah, E copy. Second employee table, the copy, we use S copy, yeah, because supervisor. We want to, look at the supervisor related information. Yeah. So we need an employee copy and a supervisor of the employees. That two copies. E copy, S copy. Yeah. All right. Then in the E table, the join condition E table, E dot super underscore SSN equals the S copy dot SSN. That's the way we join two copies of the same table. Okay, yeah. So here, if we, we use the SI and SJ. Okay, yeah. The tuples from the same table, A table, yeah. S tuples, but when we join, yeah, the first part SI, okay, yeah, independent. The second part SJ, independent of the first part, okay, SJ. Yeah. Then we apply the join condition. We apply join condition, okay, yeah. Yeah. All right. Yeah. So in this way, yeah. So what's the meaning of this select statement? The meaning is you list employees' names and their supervisor's name. Okay? Yeah. E dot first name, last name, employee's name. And at the same time, you list this employee's supervisor's name. Okay? Yeah. See? Yeah. That's the meaning. Okay? Yeah. All right. Yeah. But in this example, you can see if you do not use aliases, then very messy, very confused. Yeah. You cannot identify, which field comes from which copy. No. You do not know which copy. Okay? Yeah. So this one, you cannot skip aliases. Yeah. All right. 8.2, set operations on queries. Yeah. So this is different from table join. Yeah. Set operation. The union of two tables, intersection of two tables, and after union, intersection, and there is another one. Okay, another one. Except operation. Yeah. Yeah. So let's learn using set operations to represent queries. Yeah. All right. Borrowed from mathematical set theory. Yeah. Set theory. Set theory, we have several set operations, right? Yeah. So here, yeah, we use the same concept. Yeah. All right. The first set operation, set union. Yeah. Capital union. So the operation name, union operation. Okay. Yeah. All right. Second one, set difference. Set difference. Except. Yeah. Set intersection. Intersect. The keyword. Yeah. All right. So you can see. Set union. Yeah. If set A, this is set A, this is set B, yeah. So union, all the elements in at least one of the two sets. That's the set union. Okay? All right. Set difference. Now, sometimes you need to take the set difference operation. Yeah. Still A and B. A and B. But in A set, you want to remove those elements that belong to B set. Okay? The remaining part, yeah. Yeah. The difference, because this is the intersection part you want to remove. Okay? When you take the difference, we use except keyword. Yeah. A except B. A except B. Yeah. Remove all the elements that belong to B from A set. Intersection, that's easy. Yeah. A set, B set. Yeah. Intersection, this part. Okay. Yeah. All right. Yeah. Yeah. So with similar concept from set theory, so we can apply these three operations. Yeah. All right. Conditions for set operations. When you apply these three set operations, there is a condition. You need to check that condition. Yeah. It's not any two tables you can apply one of the three set operations. You need to make sure those two tables, when you apply one of the three set operations, you can do it. Yeah. So that condition, what's that condition? It's called a union compatible relations. The two tables must be union compatible when you join. Okay? So what do you mean union compatible, right? Yeah. Yeah. Union compatible. Yeah. So the meaning. Yeah. First, these two tables, they should have the same attributes, right? Same attributes. That's the first condition. Same attribute. The second, the attributes appear in the same order in both relations. Yeah. So the union compatible, you need to follow these two requirements. Same attribute, but if you in different order, still not union compatible. Okay? Yeah. 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 In different order. Yeah. For example, here I use a simple way. A1, A2, A3, and these two. A1, A3, A2. Okay? Same attributes, but in different order. All right? So not union compatible. Okay? So, so if two tables, you list the attributes in these two different orders, so they are not union compatible. So you cannot do any of the three set operations. Yeah. All right. Yeah. Then, but set, we know, in math, the meaning of set, we do not allow duplicate rows. Yeah. So then in SQL, we allow the duplicate rows. Yeah. So we need to change. So if we add duplicate rows, we allow duplicate rows in each table, then we need to modify the set operation to multi-set operations. Multi-set operations. Okay? Yeah. So what's the multi-set operation? Yeah. After union, you add another keyword, union all. Then you do multi-set operation. Okay? Yeah. Set A is a multi-set. Set B also multi-set. Multi-set, we allow duplicate rows in these two sets. Right. Then, this time the union version, we use union all. Then you keep the duplicate rows from these two tables. That's the multi-set operation. Yeah. Similarly, except all, yeah, intersect all. Okay? Yeah. So you keep all of the duplicated rows. Yeah. All right. Each tuple, duplicate or not, is considered as a different tuple. Okay? Yeah. Here, for example, one row repeated 3 times. Okay? Yeah, you have 3 copies. Yeah. But you treat those 3 copies as 3 different tuples. Okay? Do not treat them as the same tuple. Yeah. Copy 1, copy 2, copy 3. Yeah. So you can add a subscript. Okay? For copy 1, use subscript 1, copy 2, subscript 2, copy 3, subscript 3. You want to separate. So the 3, although they have the same tuple values, but you treat them as 3 different copies when you apply multi-set operations. Yeah. For each table, you do things like this. Okay? Yeah. All right. Yeah. 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 So that's the rules. Yeah. So when you apply the set version and a multi-set version operations. Yeah. All right. Example, set union. Yeah. Let me show you one example. Make a list of all project numbers for projects that involve an employee whose last name is Smith, either as worker or as a manager of the department that controls. Yeah, you can see this query statement is very complicated. Okay, yeah. So first thing, we want to understand the meaning. Yeah, this long query statement, we want to understand its meaning well. Yeah. Then we try to write each part. Okay. Yeah. All right. Make a list of all project numbers. Yeah, this part easy. Yeah. Project numbers for project that involve an employee. Yeah. We know each employee needs to work on several projects, right? Yeah, we can find that information. Works on table, give you the information for each employee, how many projects or what projects that employee needs to work, that information, okay? Yeah, all right, but that employee, the condition, the last name is Smith. We know there could be multiple employees with the last name Smith, right? Yeah, yeah, yeah. May not be single, only one employee with the last name Smith. It's possible there are several employees with the last name Smith. Okay, all right. Then, for those employees with last name as Smith, 2 cases. The first case as a worker Smith, okay? Yeah. Yeah. The employees with last name Smith as worker. Yeah. The second as manager. Yeah. The manager whose last name Smith. So we want to separate these 2 parts. Although these 2 parts can have overlap, right? Yeah, because the same employee can be both worker, manager. It's possible overlap. Yeah, it's fine. When we do set union operation, yeah, the overlap part, we don't worry the overlap part. Okay, yeah. All right. Yeah. So, but we need to write two select statements. One for the worker Smith, the second one for manager Smith. Then we apply the union operation to combine these two query results. Yeah. Or subquery. Yeah, you can call it the subquery results. Yeah. All right. Worker manager. Yeah. The worker part. Yeah. So let's look at the worker part. Yeah. Worker part. If we do not use the manager information, department manager information, we just use the employee table information. That's the worker part, right? Yeah. Select distinct P number. Yeah. Because some project number could be repeated many times. We want to remove the repeated copies, so we use this distinct keyword. From project table, works underscore on table, yeah, employee table. Yeah. Yeah. All right, join these three tables. Yeah. P number equals P no, although you can use aliases. Yeah. Here, for better readability, yeah, it's better to use aliases. Yeah. But this one, no aliases. Yeah. But if you want to add aliases, it's very easy. Yeah. All right. ESSN, that's the field in the works on table, ESSN, equals SSN, employee, from employee table. Yeah. Then selection condition, last name, L name equals Smith. Yeah. So this is the worker's copy. Okay. This is worker's copy. All right. The second one, manager copy. Yeah. This time, select distinct P number. Yeah. This time, we do not use the works on table. We use department table. Yeah. Because each project is controlled by one department. Yeah. There is that information. Okay. Yeah. Yeah. So we use department table. We can connect project with department directly. Yeah. Yeah. So not this time, not works on. Okay. Yeah. 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 Then we join the project table, department table, the join condition. Then department table and employee table, the join condition. Yeah. Then the last name. Yeah. Yeah. After you join, because you get the manager information, right? And the manager is the last name must be this Smith. Yeah. So that's the second subquery. The first subquery, second subquery, and you can see these two tables. Yeah. So you have two temporary tables. Temporary table 1, T1, and a temporary table T2. These two temporary tables are union compatible, right? Yeah. So check that condition. These two tables union compatible. Union compatible. So you can apply the union operation, set union operation. Yeah. Okay? Because here you use the distinct keyword. So you do not allow the duplicate copies, then it's a set. Okay? Each temporary table is a set. It's not a multi-set, right? It's a set. It's not a multi-set. Okay? Yeah. So this time you use the union operator, not the union or operator. Okay? Yeah, it's not necessary. Yeah. And actually it's worse. So you don't want to keep the duplicate rows. Yeah. So you use the union version to combine two tables. Yeah. All right. So this example. All right. Distinct. Yeah. Yeah. But another question. before we finish this example, another question I raise here for you to think about. Is it possible we can remove the distinct keywords here? Yeah. Our goal, we want to remove the duplicate copies, right? Our goal, okay? Yeah. So here, just to raise this question for you to think about. Yeah. Because when we use the union operation, this union operation, we apply it. It's a set operation, right? We treat each table as a set. If it's a set, then duplicate rows are removed for a set. Okay? Yeah, so here, think about that. Okay? That logic. Yeah. Because set operation does not allow duplicate rows. Okay? Yeah. So then, if duplicate rows appear, then they are eliminated automatically. Okay? Yeah, think about that. Yeah. So you can test it. Yeah. So we can run this example, we can test it and see if the duplicate, yeah. But the data, yeah, the problem is the data, so before we apply the union operation, we want to look at the result of each temporary table, T1, T2. Yeah. So we want to see if there are duplicate rows. Yeah. Yeah. So you can guess, you know, actually some of the project numbers will be repeated. Yeah. Yeah. But you do not use the distinct keyword to remove them. Yeah. You just apply the union operation directly and see if you can remove the duplicate copies. Yeah. So that's a interesting example you can try. Okay. All right. So that's the set union operation. 8.3, string pattern matching. Yeah. Another very useful feature in our query statements, pattern matching. In order to search the information, yeah, many times we need to apply string pattern matching methods to make our search, information search, data search more precise. Yeah. Here, let me give you some methods. Yeah. String pattern matching, yeah, using partial string matching. Yeah. So the first way, very simple. Okay, partial string matching, simple way. So there is a special operator, comparison operator called a like operator. Like for partial string matching, that operator. Yeah. So this is a simple way. Yeah. So we have a simple way this way, and then we have a complex way. Yeah. Another way. So to describe complex pattern. So this like operator, we can describe simple patterns. Yeah. But there is an advanced complex pattern description method. Yeah, we will learn later. Well, so this way, very easy, very straightforward. And we need to use special characters for pattern description. The special character first, percent sign replaces an arbitrary number of 0 or more characters. Okay, percent sign, even 0, you can use percent represent, or several characters, any number of characters, yeah, you can use percent sign represent. Okay, just like star. Okay, we use star to represent. In Unix, we use that star operator. We can represent any number of characters, right? Here, it's different from Unix. Here in SQL, we use this percent sign to represent any number of characters, including 0. Okay. If nothing, we can still use the percent sign to match nothing, no character, empty character. Then underscore replaces a single character. Okay? Single character we use underscore. Okay, yeah. In Unix we use question mark, right? Question mark for single, but in SQL it's different. In SQL, this underscore represents single character. Okay, all right. Beware of the performance issues. Yeah, because this this point tells you, because sometimes when you search your data using these operators in a large text body, the performance could be slow. Okay, when you apply, so be aware of it. Could be slow. Okay, this pattern matching. But if you search small amount of data, then should be very fast. If a large amount of data, then it could be slow. The matching, like this could be slow. Okay, that's why if you remember last time I talked about Google search engine, if you do, you cannot not use this way to do the keywords based search real time, because it's too slow. Okay, you cannot use this way. So the Google search engine, we do pre-calculation that way. You can make it faster. You cannot use this way to make your search very fast. Related to the keywords based search. All right, so you need to be aware of it. Specify escape character, because you have some special character. This percent sign is a special character, right? Because its meaning, it's different from the literal percent sign, right? This underscore is a special character. But sometimes people want to use literal version of the character, not as a special character, right? Sometimes people want to use its original meaning, not a special meaning. You can use a escape character, but in SQL, the escape character is not a fix. In other languages, escape we use backslash, right? In other programming languages, Java, C, Unix, we use backslash, and JavaScript and many other, PHP, many other programming languages. When we HTML, right? Many other programming languages. When we need to escape some character, we use backslash, right? But here, in SQL, it's different. You need to specify. You can use special way. And escape character is specified after the string using the keyword escape. You need to declare it. Then you can apply it. Okay. Example. All right. Here you use backslash as escape character. Backslash escape. But you need to use escape keyword to declare this backslash as the escape character. Okay? You need to do it explicitly. Otherwise, SQL won't treat it as an escape character. Okay? So you can see SQL rules are different from many other programming language, the rules used. All right. Let me see. Yeah, less than 10 minutes left. Yeah, let me at least give you one example. 8.4, use regular expressions for patterns. This is advanced pattern matching method. Regular expressions. Because when you use this way, you can describe many complex patterns. Yeah. The first way, use like operator, you can only describe simple patterns. Yeah. But this way, you can describe many complex patterns in a very accurate, yeah, because you can address a lot of subtle points. Yeah. All right. Yeah. Let me show you one example. Okay. Yeah. Because later we need to use one whole class to learn regular expression, using regular expression in SQL statements. Yeah. So one whole class. Today I only show you one example. Okay. One simple example. All right. Yeah. Look at this question. List the name and address for those employees whose addresses, the condition on address, the string, addresses satisfy the condition. What condition? The street number has exact 4 digits. In the address string, the first few characters, that's the street number, right? The street number, you can have 2 characters, 3 characters, 4, 5, several characters, but you only select exact 4 digits as the street name. You want to describe the pattern precisely 3, exactly 4 digits. Now, here, let's see how to use regular expression to describe this pattern. Yeah. Here, we only need to focus on the pattern part. Yeah. Because the other part's relatively easy, pretty straightforward. Yeah. The hard part is the pattern description part, relatively hard. Yeah. All right. Here, this is the statement, select statement. Yeah, let me explain. Yeah. The pattern matching part, where in the where clause, this is the pattern matching part. Yeah. Other parts pretty straightforward, right? First name, last name, address from table employee. Yeah, here, we only need to focus on how to use regular expression. Here we use a special operator. This regexp, this is the regular expression matching operator. Yeah, this operator. Yeah. Address. Yeah. Regexp operator, then the pattern expression using the regular expression syntax. Syntax in our next class, I will give you, many syntax rules. So we learn. Yeah. Today here, we only show you one example. All right. Let me explain. So what's the meaning? Yeah. Because it's not easy to understand. Yeah. If you are not familiar with regular expression syntax, yeah, it's not easy to understand the meaning of this pattern here. Yeah. Let me explain. Yeah. Bit by bit. Yeah, because several points. Yeah. Bit by bit. Yeah. First, that veg sign. Yeah. So that little veg sign. Yeah. Yeah. Or hat. Yeah. So whatever you call. Yeah. Okay. Yeah. Hat. Yeah. Yeah. So that symbol, that means the beginning of the matching, the beginning of the string, the very beginning. Yeah. When you use this notation, because street number appears at the beginning of the address string, right? Yeah. So you should go to the beginning of the address string to start your pattern description. Yeah, all right. Then a pair of brackets describe the pattern description right, after the beginning point. Right after that, you want to describe what characters follow that beginning point. Okay? 0-9 digit. Each character must be a digit from 0 through 9 digit. Okay? Yeah? 4 digit, right? Yeah. Digit. You need to repeat digit character 4 times. Okay? Yeah. So this represents one of the digit, yeah, but only for one character. Okay? A pair of bracket give you options. The options from 0 digit through digit 9, digit 0 through digit 9, yeah, dash through, okay? 0, 1, 2, 3, all the way through 9. So 0-9, consecutive digits, okay? Dash means the consecutive, okay? Yeah, you use this dash sign, yeah, consecutive, okay? Yeah. Later you can use A-E, yeah, A, B, C, D, E, consecutive. So you don't need to list all of them, okay? A-Z, for example, yeah. So this way, you can make it simple. Make your pattern description simple. Here, 0-9, okay, to describe one single digit. Then curly braces, a pair of curly braces inside the 4. You want to specify the previous pattern, yeah, previous one, yeah, that character, that digit character should be repeated 4 times, 4 digit, right? Exactly 4 digit. So that digit character should be repeated 4 times. So this 4 means, yeah, number of times the pattern repeated, 4 times. All right. Then exactly 4 digits. How do you represent exact 4 digits? It cannot be 5 digits. You repeat it 4 times, but if the digit number 5 follows the 4 digits, you just repeat it. That's not good, right? So after the digit repeated 4 times, you need to add a space character after. Space character. No 5th character. Yeah. After you add a space character right after the 4 digits, then immediately you insert a space character. Then it does not take the 5 digit, 6 digit, those cases. So you stop those cases. Okay? All right. Then after the space character, nothing, no description. After the space character, that means anything is allowed. Okay? If you do not describe anything, then anything is allowed. Okay? All right. Yeah, already we run out of time. Yeah. So let's stop right here. Yeah. Next time we complete the remaining slides. Yeah, then we move to the next one. We will learn pattern matching by regular expressions. Here only the first example, regular expression example. All right, yeah, that's it. Yeah.